Hello, my name is Hannah Hunde. So today I'm going to be working with conservation of momentum. This is Physics 221 recorded lab activity with Dr. Zita Fadai. So today we're going to be looking at what is the conservation of momentum. First of all, momentum is the product of mass and velocity of an object. So uh, the law of conservation of momentum stated that the total momentum of an isolated system is conserved, which means, as we can see in this figure, the total momentum of the two objects before colliding or before any interaction is similar to the total momentum after the interaction or the collision. This is due to the Newton's third law of action and reaction force, Newton's third law of motion. So for every action there is an opposite and equal reaction. So due to that, the momentum before and momentum after a collision or an interaction is going to be the same. So mass times velocity of object 1 plus mass times velocity of object 2 before the collision is equals to mass times velocity of object 1 plus mass times velocity of object 2 after the collision. So collision is basically an interaction between two objects. So we consider elastic collision when the total kinetic energy and momentum are conserved. So today we're going to see two types of collision. The head-on collision when two objects collide at the center of mass, and the glancing collision when two objects collide at a certain angle. So let's see this simulation, which is going to show us how this happens. So we have two balls or two objects, object 1 and object 2, which have the same mass, which is 1 kilogram, and object 1 has a velocity of 0.50 meter per second, and object 2 is at rest. So as we can see here, the total momentum of object 1 is 0.50 kilogram meter per second, and like object 2 has no momentum because it is at rest. So that means the total momentum now or before any interaction is 0.50. So let's see what happens when the two objects are gonna collide or are interacting. So ball 1 is gonna hit ball 2 at a certain speed at the center of mass. So ball 1 is hitting ball 2 and then stopping. That means ball 2 is going to have the same velocity that ball 1 had before the collision. And as we can see here at the yellow box, we can see that ball 2 has a momentum of 0.50 meter per second, kilogram meter per second, and a velocity of 0.50 meter per second. So the total momentum after the collision is still 0.50 meter per kilogram meter per second per second. So that is what we call the conservation of momentum and a head-on collision. Let's see the other type of collision with a simulation. So this is another simulation which shows a glancing collision. So object 1 is moving at a certain speed, but as you can see in the velocity vector is slanted a little bit down, and object 2 is at rest. Still, the two objects have the same velocity, the same mass, so we can see that what will happen once object 1 hits object 2. So as you can see, object 1 and object 2, the velocity of object 1 is decreases and the velocity of object 2 increases. So now the sum of the two momentum is going to be equal to the momentum before the collision. This is what we call a glancing collision. So the best example for a real life physics is pool. So what we call a head-on collision in this case is a stop shot, and I'm not really sure what we call the glancing collision. And let's see how the pool uses the conservation of momentum principle. So we have two billiard balls, the yellow billiard ball and the black billiard ball. So once the black billiard ball hits the yellow ball, what will happen? This is a head-on collision. So we are assuming the yellow ball will move on with the same velocity that the black ball had before, and the black ball will completely stop. Let's see what happens. As you can see, the black ball stopped and the yellow ball went with the same velocity as the black ball had before the collision. This is what we call a head-on collision. Let's see the other type of collision. This is a glancing collision. Once the ball hits the other ball, they don't hit at the center of mass, they hit at a certain angle. So each ball is going to go into different action, into different direction, but the ball is going to have the sum of the two momentum is going to be the same with the sum of the two momentum before that interaction or the collision. So this is what we do in real life using physics. Thank you for watching this video.